Right now you are standing on the thinnest of skins, above a hidden world. Beneath your feet lies a place no human has ever seen. A journey to the center of the earth would take you through fire and crushing dark. So how do we know what is actually down there? The deepest hole we ever drilled reached just 12 kilometers down. Compared to the whole planet, that's thinner than the skin of an apple. We stopped because the rock grew too hot and soft to drill. The center of the earth is over 6,000 kilometers down. We will never dig there. So the inside had to be revealed another way. The answer comes from earthquakes. Every big quake sends waves rippling through the entire planet. Seismographs all over the world record when those waves arrive. There are two main kinds, fast P waves and slower S waves. As they pass through the Earth, the waves bend and speed up and slow down. Each hidden boundary bends them in a telltale way. And here is the crucial clue. S waves cannot travel through liquid. On the far side of the planet, the S waves simply vanish. That shadow revealed a stunning fact. Part of Earth's core is liquid. Piece by piece, the waves mapped four great layers. On top, the crust, the thin, cold rock we live on. Below it, the mantle, hot rock that creeps like thick tar. Over millions of years, this rock slowly churns and flows. Deeper still swirls the outer core, an ocean of liquid metal. And at the very heart sits the inner core, a solid metal ball. From surface to center is a journey of 6,000 kilometers. The mantle alone is nearly 3,000 kilometers thick. Fall through it all, and the world would transform around you. With every kilometer, it grows hotter and the pressure climbs. At the center, the temperature reaches thousands of degrees. The core is nearly as hot as the surface of the sun. The core is made mostly of iron and nickel. We know because iron meteorites are shards of shattered planet cores, and the whole Earth is far too heavy to be rock alone. But here is a paradox. The inner core is hotter than the liquid around it. Yet it stays solid, squeezed by unimaginable pressure. That pressure forces the iron atoms to lock rigidly in place. Slowly, as the Earth cools, this solid ball is growing. Liquid iron freezes onto it a few millimeters every year. And that swirling liquid metal does something extraordinary. The hot liquid iron rises, sinks, and churns without stop. The spin of the Earth twists those currents into spirals. Moving metal makes electric currents, and currents make magnetism. Together they turn our planet into a giant magnet. An invisible magnetic field erupts from the core and wraps the world. It is the force that swings every compass needle north. Far into space, it forms a protective bubble called the magnetosphere. And we need that bubble, because the sun is firing at us. The sun hurls out a constant storm of charged particles. Our magnetic field catches that wind and sweeps it aside. It works like an invisible shield wrapped around the whole planet. Some particles slip down to the poles and light up the sky. Those glowing curtains, the aurora, are the shield at work. Without it, that solar wind would strip our air away. We know, because that is exactly what happened to Mars. Mars lost its magnetic field, then lost its atmosphere and its water. Earth's molten heart is the reason our world stayed alive. The metal ocean, thousands of kilometers below, keeps you breathing. But this shield is not fixed, it drifts and shifts. The magnetic North Pole is wandering across the Arctic toward Siberia. In recent years, it has been racing tens of kilometers annually. And every so often, the whole field flips upside down. North becomes south, and south becomes north. This is written into the rocks of the ocean floor. As new crust forms, it freezes the field's direction like a tape recorder. Row after row of magnetic stripes record every ancient flip. The last full reversal happened about 780,000 years ago. We still cannot predict when the next one will come. Even the inner core holds fresh surprises. For decades we thought it spun a little faster than the rest of Earth. But recent studies suggest its spin may have recently slowed and paused. It may even rock gently back and forth over decades. The deepest part of our world is still full of mystery, and every earthquake gives us one more glimpse inside. A thin crust, a churning mantle, and a heart of iron. A hidden engine that builds a shield and lets life survive. So the next time you feel solid ground beneath you, remember, you are riding on a thin shell above an ocean of molten metal. A furnace as hot as the sun, spinning 4,000 kilometers below. And it has been quietly keeping you alive this whole time. If you enjoy this kind of deep science, subscribe and I'll see you next time.